Welcome to Mathematics Alive, Algebra Lesson 34, Wind and Water Current Problems. Problem number 1, it takes 2 hours for a motorboat to travel 112 miles downstream. The same boat can travel 72 miles upstream in 3 hours. Find the rates of the boat in still water and the water current rate. So let x be the rate of the boat in still water and let y be the rate of the water current. And then we will represent the first sentence with an equation. Okay, it takes 2 hours for the motorboat, and the motorboat is represented by x, to travel 112 miles downstream. So downstream, the rate of the motorboat and the rate of the water current are going in the same direction. So we will add the two rates. So we can illustrate that with this illustration. And here is the motorboat. It's going downstream, and the water current is also going downstream. So this is the x and this is the y. So going downstream, the representation is x plus y. So we have 112 miles in 2 hours, and we just simply divide that. So we have 56 miles per hour. Now, if the motorboat is going upstream, then we have the rate of the motorboat will be counteracted by the rate of the water current. So the y will be negative because there is an opposite direction. So we'll have x minus y is equal to 72 miles, and it will take 3 hours for the same boat to travel 72 miles. So 72 miles over 3 is equal to 24 miles per hour. And we can directly subtract or add these two. So we have y minus y equals 0, and we have eliminated y. So we have 2x is equal to, we'll add here because this is the simplified amount. So we have 0 and 6, 7, 8, 80 miles per hour. And then we have this equation, 2x is equal to 80 miles per hour. Oh, where's the 0? And then we divide by 2. So x is equal to 40 miles per hour. And then substituting this value to any of the two equations, we can solve for the value of y. And we will use equation 1. Equation 1. So x plus y equals 56. Then we substitute the value of x. 40 plus y is equal to 56. And then we subtract 40 from both sides. So y is equal to 16 miles per hour. And then we can checking this, we have we can use any of the two equations. So we will use equation 2. Equation 2, x minus y equals um, 24, and then substitute x is equal to 40, and then y is equal to 16 equals 24. So 24 equals 24. So we got the correct answers. Our value for x is 40 miles per hour. That's the rate of the motorboat in still water. And the rate of the water current is 16 miles per hour. Problem number 2, we have, with the wind, an airplane flies 335 miles per hour. Against the wind, it can fly 305 miles per hour. What is the average speed of the plane in still air, and what is the speed of the wind? So we let x be the rate of the speed of the airplane in still air, and let y be the rate of the wind. And if the airplane is flying with the wind in the same direction, so we add the x and the y. So our equation will be x plus y is equal to 335 miles per hour. And if the direction of the wind is going in an opposite direction, so if it is going this way, so the speed of the wind will counteract the speed of the airplane, so it will be subtracted. So x minus y is equal to 305 miles per hour. And then we can directly add the two equations, and we have x plus x is equal to 2x, and y minus y is 0, and we have 640 miles per hour. Then we divide by 2 on both sides. So x is equal to 320 miles per hour. And then we substitute this value to any of the two equations. We will substitute in equation 1. So we have equation 1, x is 320 plus y equals 335. So y equals 335 minus 320. So we have y is equal to 15 miles per hour. And then we can check with equation 2. Equation 2, we have x is 320 minus y is 15. Equation 2. So we'll have 305. So 305 equals 305. Check. Our answers are correct. The speed of the air, or the speed of the airplane in still air is 320, and the speed of the rate of the wind is 15 miles per hour. Here is problem number 3. Flying with the wind, a bird was able to make 150 kilometers an hour. But flying against the wind with only half the velocity of the first wind, it could make only 30 kilometers per hour. Find the velocity of the wind and the bird's rate of flying in still air. So we let x be the rate of the birds flying in still air, and let y be the rate of the wind. And then if we combine the rate of the bird and the rate of the wind, because they are flying together in the same direction, then we have 150 kilometers per hour. Then equation 2, we have number second sentence, we have flying against the wind with only half the velocity of the first wind. It could make only 30 kilometers per hour. So we subtract the velocity of the wind, which is divided by 2, because it's only half the velocity of the first wind. So we have x minus y over 2 is equal to 30 kilometers per hour. And then we will simplify equation 2 to remove the denominator. We will multiply by 2. So 2 times equation 2 is equal to 2x minus y is equal to 60 kph. And we will combine equation 1 here. Equation 1, just copy x plus y equals 150 kph. Then directly add the two equations. We have 3x 0 equals 210 kph. Then dividing both sides by 3, we have x equals 70 kilometers per hour. And substituting the value of x to equation 1, we have equation 1, 70 plus y equals 150. And then solving for y, we have 150 minus 70. So y is equal to 80 kilometers per hour. And then checking, we will use equation 2, the simplified form of equation 2. So we'll use this. 2x minus y is equal to 60. So 2 times x, 70, minus y equals 60. Then we have 140 minus 80 equals 60. 60 equals 60. Check. We got the correct answer. And so the rate of the bird in still air is 70 kilometers per hour, and the rate of the wind is stronger. It is 80 kilometers per hour. And for our problem number 4, we have a boy rows 6 miles against the current in 2 hours and 5 miles downstream in 1 hour. Find the rate of the boy's rowing in still water and the rate of the water current. We let x be the rate of the boy's rowing in still water and y be the rate of the water current. And then the first sentence here is, the boy rows 6 miles against the current in 2 hours. So we let x minus y be the situation. The water current is against the boat, so we subtract the water current from x. And it takes 6 miles in 2 hours, or simply 3 miles per hour. And then it takes 5 miles downstream in 1 hour. So downstream the boat and the water current are in the same direction. So we have x plus y is equal to 5 miles per hour. And we can simply add the two equations. We have x plus x, 2x, then 0. And then we add here, we have 8 miles per hour. And then we divide both sides of the equation by 2. So we have 2x is equal to 8. Then divide by 2. X is equal to 4 miles per hour. And we substitute x is equal to 4 in equation 2. Equation 2, we have 4 plus y is equal to 5. So y is equal to 5 minus 4, or y is equal to 1 mph, 1 mile per hour. And then you will check using the first equation, equation 1. So x is equal to 4 minus y minus 1 is equal to 3. So 3 is equal to 3. Check. Our answers are: the rate of the boys rowing in still water is 4 miles per hour, and the rate of the water current is 1 mile per hour. If you find this video helpful to you, then please share it to your friends, like it, and subscribe to this channel by clicking the button below. Thanks for watching, and bye-bye.